Now I am discussing with the subtopic approximations of the main topic of the chapter application of derivatives. In fact, approximating something with the help of differentiation comes under this subtopic. It is like if some small change is made in one variable in the independent variable, then what change will be observed in the dependent variable. This kind of problems will be dealt in the topic approximation, will be clear you very much with the help of an example which I am taking. Find the value of root of 25.3 using differentials. Here I can assume let the value of x, because I want to find the square root of 25.3. A class 8 student even can solve it, but using the differential he or she will not be able to do it. So, if I take x is 25 because this is the closest perfect square to the number which is given, then a small change dx is made, then x plus dx become 25.3. If I say with the help of this what is the answer of dx, it is 25.3 minus 25, this becomes 0.3. Small change in the x in the independent variable is made, then what is the required change in the value of y? You can see here, if x is 25 and function y or fx is equals to root x type is required. In this situation, what is the answer of y? Y is what? 5. X is 25, so y is root 25, so y is what? 5. Now what we want to calculate, what is the answer of y plus dy? We can calculate this answer only if we know what is the answer of dy. To obtain it, y is equals to root x will be differentiated both sides with respect to x. So, the answer of dy by dx become 1 by 2 root x. This become 1 by 2 root x and x is what? 25. So, we can say the value of dy is equals to 1 upon 2 root of 25 into dx. The value of root 25 is 5, 5 into is 10, the value of dx is 0.3. So, we can say it becomes 0.3 upon 10 is equals to 0.03. This is the answer of dy. We want to find the net answer y plus dy. So, the answer of y plus dy become answer of y in the initial situation when x is 25 is 5. Answer of dy is obtained by using the differentials is 0.03. So, y plus dy or net the square root of 25.3 is 5.03. This is the answer. So, we can use differentials for finding the approximations in the problems. Now, I explain you that how we can use the approximation to solve some word problems. Find the approximate change in the volume V of a cube of side x meter caused by increase in its side by 2%. Suppose initial length of side is x. Its changed side is x plus dx. Percentage is given, that is dx upon x into 100. The answer is 2%. They are asking what is the change in the volume. Let us suppose initial volume were V. Change is observed dV out of V into 100. dV upon V into 100 they are looking for. We know that the volume of the cube is given by x cube. On differentiating both sides with respect to x, we will get dV upon dx is 3x square. When dx is crossed here, we can say the answer of dv is 3x square into dx. We want to calculate dv upon v. So, divided by v, divided by v. Also percentage, so multiplied by 100, multiplied by 100. In place of v, what we can replace x cube. So, this result will come 3x square into dx into 100 divided by x cube. This x square and x cube will give us net x. So, this dv upon v into 100, that is the change of the percentage in the volume of the cube caused by 2% change in the edge, will come like this 3 dx, because this x square and x cube will left x into 100. This is dx upon x into 100, caused here 2%, so we will put here what? 2. So, this become 6%, because this is 2, 3 ja 6. Hence 6% of change, or we can say 0.06. To remove the percentage, we need to apply denominator in 100. So, net answer, final answer without percentage is 0.06 caused by 2% change in the edge of the cube, the change in the volume.